The first objective, explain systems performance. Systems performance is the study of everything from the application down to metal. We often hear the word full stack described, engineers saying that they are full stack engineers, and the term full stack is used differently. And so it's often used to describe the application stack. And so you will work on the application, database, load balancers, all of those components. And then that makes you a full stack engineer. We tend to say full stack in systems to mean everything from the application down to metal. Systems performance is about finding all these bugs. Within the kernel, when you find issues, they are often, there's really two types of issues that we're finding. Small tuning and incremental changes that give us 1% better performance, 5% better performance, 10%. It's not a lot. Then there are eliminating outliers. And by eliminating outliers, it is where the scheduler has done something dumb and the thread has gone to sleep for a second, or there's a storage I/O that's taking a second. And it's most of the time things are working fine, but you will be able to make an outlier go 1,000 times faster because you've eliminated it. But the result of working on the system is I either gave you 10% or I made that outlier go away. The result of working on the system is not, I made your application run 10 times faster. And because of that, a lot of the startups don't have time to look inside the system because they think if it's the really major issues are in the application, then I should focus all of my efforts in the application. Because that's when I could make a code path change and things can go 10 times faster for all of the I/O, not just the outliers. With systems performance, we do look at the application as well, and we also look at the application from operating system context. And so what many of these environments are missing out on is that understanding the application from its own tools or from its virtual machine tools works fine, but performance is really complicated, and this is a different way to look inside the application, and it can answer some problems that you can't find with application tools alone. The operating system could be interfering with the application in a way that it's very transparent when you're using the operating system tools, but is very difficult to know about when you're inside the application. And so we can get the 10x and 1,000. I did a blog post of a 2,000x win, analyzed using system tools of an application. That was grep using lang equals something that wasn't C. So anyway, that's one problem with systems performance is that many companies don't do much of it because they assume they worry about the big wins and they assume it's not going to lead to the big wins, but it does because you're using the system tools to look at the application. So 3 types of wins: tuning, 10%, outliers, eliminate, and then big wins, especially if it's up in the application. So that's systems performance. It really is everything.